Receiverin proudly presents Liposomal versus Oxidized Vitamin C and Do-It-Yourself Dehydroascorbic Acid, the Amazing Green Smoothie. Hello, I'm Doug Kitt with Receiverin Company of Salt Lake City, Utah. Today I'm going to show you how you can make your own dehydroascorbic acid, a form of oxidized vitamin C, for supplementing your diet. And as the title implies, we're going to be making a vegetable puree that is often referred to as a green smoothie. But what you'll learn is that in scientific terms, we're going to conduct a natural biochemical synthesis reaction. And we'll utilize a sensitive redox indicator to monitor the progress of this reaction. In short, I'm going to teach you how to be a successful biochemist. And amazingly, we're going to do this in the kitchen at home with a blender, plain old zucchini squash, and common vitamin C, and other materials that you probably already have or that you can easily and economically obtain. But maybe you're asking yourself, why would I want to make a dehydroascorbic acid dietary supplement? What is this stuff? What's so special about it? And why would I want to use it instead of my current vitamin C supplement? Well, these are all things we're going to cover in this video. But one reason is to raise the level of vitamin C in your bloodstream higher than can be achieved by eating regular old vitamin C tablets. Liposomal vitamin C claims to accomplish this. Unfortunately, it doesn't appear to. But before I get to discussing why you will want to use dehydroascorbic acid instead of liposomal vitamin C, I think we should take a few minutes to discuss the natural ways that vitamin C is absorbed. After that, we'll examine some scientific literature to see just what real evidence there is to support using liposomal vitamin C and why you should consider switching to something better. Common vitamin C. Each of the tablets in this jar contains 1,000 milligrams or 1 gram of ascorbic acid. This is the most common supplemental form of vitamin C you will find, but you should be aware that there are others. In fact, if we take a look at the Wikipedia vitamin C webpage, this is what we find. Vitamin C refers to a number of vitamins that have vitamin C activity in animals, including ascorbic acid and its salts, and some oxidized forms of the molecule like dehydroascorbic acid. So instead of using the blanket term vitamin C, from now on when I say AA, I'm referring to l-ascorbic acid. And when I say DHAA, I'm referring to l-dehydroascorbic acid. And anytime I say vitamin C, I will be talking about just these two forms, because these are the two most common natural forms of the vitamin and represent the majority of what you normally eat. Typically about 10 to 20% of the vitamin C you get from food is DHAA and the remainder is AA. Now let's talk about how vitamin C is absorbed in your body. And for that, we'll start with the cells that line your digestive tract, the first barrier to vitamin C absorption. All cells have a cell membrane that encloses them, and it is across this cell membrane where absorption actually occurs. To get an idea of what this looks like, let's take a quick look at the Wikipedia cell membrane page. This image shows a diagrammatic representation of a typical cell. For the purpose of this discussion, I want you to imagine that this is one of the nutrient-absorbing cells that line your intestine. You can see that the cell membrane is a very complex structure with lots of different components. One component is known as a protein channel or a transport protein. It is depicted as a little tube that leads from the outside of the cell into the inside, because its job is to bring nutrients from the outside of the cell into the inside. The cells that line your digestive tract have a specific type of transport protein called SVCT. When you eat AA, it is this transporter that brings the vitamin from your digestive tract into your intestinal cells to finally be absorbed into your bloodstream. SVCT is what is known as an active transporter, meaning it requires energy to fuel the absorption process of AA. Also, as compared to some other types of transport proteins, SVCT transporters are present in somewhat small amounts. Taken together, that means the absorption of AA is limited. Let's take a look at a different diagram for just a minute. This page comes from teaching materials used in a college-level nutrition class at Kansas State University. First note that this confirms what I told you already, that a significant portion of the vitamin C you eat naturally is DHAA. Also, that AA is transported into the cell by the SVCT protein and finally into the blood. And finally, to emphasize that this mechanism is saturable, meaning that at high concentrations it reaches a threshold where it cannot take up ascorbic acid any faster. Thus, there is a limit to how much can be taken up through this mechanism. Now, when it comes to absorbing a recommended daily allowance of vitamin C, this isn't a problem. That's only about 100 milligrams. In fact, if you want to take more, according to this study, you can eat up to about 500 milligrams of AA before you saturate this SVCT absorption mechanism. But wait a second, 500 milligrams is only half of one of these tablets. So what does that mean? Well, in short, if you're trying to greatly increase the vitamin C in your bloodstream by eating lots of these, it just isn't going to work very well. What you're looking for is an additional or alternate pathway that can move vitamin C from the gut into the bloodstream at a faster rate. This higher absorption is what liposomal vitamin C promises. Perhaps you already know that liposomal C is a mixture containing AA and a phospholipid called phosphatidylcholine. The claim is that AA is absorbed more readily because it is delivered in a biological capsule called a liposome, which allows the AA to easily cross into the cell. It is an interesting theory, but I think before we buy into it, we ought to take a look at the results. And by results, I mean absorption. It is relatively simple to test the absorption of any kind of vitamin C preparation by simply measuring the blood levels before and after eating it. Here we're going to examine the results of a liposomal C absorption study, and then later we'll compare these results to results we obtained with the green smoothie that I'm going to teach you how to make. In this study, scientists began by giving a person 5 grams of common AA tablets and then measured the amount in her blood plasma at various times afterwards. This was a control. The next day, they gave the same person 5 grams of liposomal C and measured her levels again, before and at various times after eating the vitamin C preparation. For the first day, the control, this is what the data looked like. Having looked at these types of studies before, I can tell you it is a pretty typical absorption profile of AA. But that isn't the important part. The next day, the person ate 5 grams of liposomal C. And here are the results. If you think this data look the same as the control, I agree. There doesn't appear to be any significant difference between liposomal C and regular vitamin C tablets. But don't despair just yet. Let's talk about another method for driving up blood levels of vitamin C. And this time, no hocus pocus. This time, let's talk about a well-known, scientifically valid mechanism that has been proven in many scientific studies. Let's talk about an alternative pathway for absorbing vitamin C that your body already has built in. DHAA is absorbed by the cells in your digestive tract using a different transport protein than AA, a transporter called GLUT. Let's look again at the teaching materials from the Kansas State University nutrition class. The name GLUT, or G-L-U-T, is derived from the words glucose transporter and comes from the fact that these transporters were first discovered as proteins for transporting glucose, or sugar, into the cell. Interestingly, these transport proteins are multifunctional, and it was later discovered that they are also the transporters for DHAA. Well, since glucose is the most common sugar in the diet, your intestinal cells have a lot of these GLUT transporters. That means your intestinal cells have a great capacity to absorb DHAA. And on top of that, GLUT transporters are a type known as passive transporters. Passive transporters don't require any extra energy for absorption and therefore move DHAA into the cells much faster than SVCT transports AA. DHAA is converted into AA once it gets inside the cell. If you find some time, you should read more about DHAA, especially the reports from scientific journals. They are fascinating. But what I wanted to do is reproduce the liposomal study, this time using DHAA instead of liposomal C. So here's what I did. I tested 3 different vitamin C preparations on myself on 3 consecutive days. On the first day, a fasting baseline blood sample was taken. Then I drank 5 grams of l-ascorbic acid dissolved in water. At 30, 60, and 120 minutes after I drank it, blood samples were also taken. On the second day, I did the identical experiment, except I drank the green smoothie that we are going to make, prepared to contain 5 grams of DHAA. And finally, on the third day, I again did a similar test, except that I drank a green smoothie, to which I also added 5 grams of glucose. I used vitamin C doses of 5 grams so that I could actually directly compare the results with the first study. If you'd like to see the actual lab reports from my study, just visit our website. And here are my results shown in red. As you can see, similar to the other study participant, I had a typical absorption profile of common AA. But look what happened when I drank 5 grams of DHAA. My plasma level shot up to 460 in 30 minutes and to 472 at 60 minutes, over 5 times higher than baseline and more than twice as high as the peak level from 5 grams of AA. These are the highest levels ever reported for any size dose of any oral form of vitamin C. In fact, in a different experiment reported in the same study to which I've been referring, 2 subjects each took a whopping 36-gram dose of liposomal vitamin C and never achieved plasma levels this high. What they both achieved was diarrhea from eating such a huge dose of liposomal C. Now remember that I explained that DHAA is absorbed by the same receptors as absorbed glucose? That's why I added an equal amount of glucose to the test on the third day to see if the sugar would compete with DHAA for absorption. And here are those results shown in green. As you can see, the plasma levels are not as high as on the second day. This confirms that the glucose transporters are involved exactly as all the previous scientific research has shown. And it also teaches us something about how to use this green smoothie. It is clear that if we want to achieve the highest possible blood levels, we should not add anything to the recipe that contains sugar, and we should probably take it at least an hour before or after any other food. Well, it seems like a no-brainer. If you want to increase vitamin C levels in the bloodstream, the way to do it is with DHAA. But there is a problem. Where do you get DHAA? It is difficult to produce and has only limited stability. In fact, at the present time, there's only one commercially available dietary supplement in the whole world that has significant amounts of DHAA. It's called Receiverin 50/50, and it's a very fine product. It can be applied topically to increase skin levels of vitamin C for skin care. It can be used as a mouth rinse or gargle to specifically increase vitamin C levels in the gums, mouth, and throat. It can be taken orally as a dietary supplement to provide vitamin C in both of its natural forms, just like what you get from eating fresh green vegetables. The Receiverin 50/50 was never intended as a source of vitamin C in such large doses. So if you're interested in eating a whole gram or more of DHAA, Receiverin 50/50 will work, but it will be quite expensive. So today, the only way you're going to get DHAA in gram quantities that most people can afford is to make it yourself, as I'm going to demonstrate. So let's talk about the science behind this project for a minute. There is an enzyme called ascorbic acid oxidase, or AAO. It's common in many plants, but zucchini squash has a higher concentration of it than any other known source. AAO catalyzes this reaction, the oxidation of ascorbic acid to dehydroascorbic acid. Now, all we're going to do basically is puree zucchini in the blender and add AA to it. The enzyme in the zucchini will catalyze the conversion of AA into DHAA using oxygen from the air. But we need to be careful to control certain conditions of the reaction to make sure it works, including the pH or acidity, the concentration of the reactants, and the temperature. Take a look at this graph. The AAO enzyme has a pH range that is optimal for its activity. We need to keep our puree within this optimal pH range, and very importantly, we don't want to exceed certain pH levels. If we make the solution too acidic, it might kill the activity of the enzyme completely and the reaction won't work. On the other hand, even though the enzyme is active at high pH, DHAA is unstable at high pH and breaks down quite rapidly, so we need to balance the pH carefully. The enzyme also has an optimal temperature range. I'll explain why this is important and how we control it in just a few minutes. Also, don't forget that oxygen is a crucial substrate for this reaction. It will require the amount of oxygen in 1 cup of air to oxidize each gram of AA. I'll show you how to assure that the puree gets plenty of air. We need a way to monitor this reaction so that we know when the AA has all been converted to DHAA. There's a very simple way to test the solution for the presence of AA. We're going to use a starch iodine redox indicator reagent. It's this blue solution I have here. Basically, it works like this. We add 1 drop of puree to 1 drop of the blue indicator solution. If the puree contains AA, then the solution turns clear. If the puree doesn't contain AA, then the solution remains blue. It's as simple as that. It's based on the reducing activity of AA on iodine, or put another way, it's based on the oxidizing activity of iodine on AA. That's why we refer to it as a redox indicator. The word redox is simply a contraction of the phrase reduction oxidation. I'm not going to go into any more detail about this reagent. Just follow my instructions, prepare and use it as I describe, and you will know it's working because you can see it. You know, I'm a scientist with over 40 years of experience in the clinical, pharmaceutical, and biotechnology industries. Today, my business is vitamin C. And even though Receiverin is a small company, we have a laboratory with all the equipment, supplies, reagents, and methods necessary to evaluate and optimize this reaction, including analytical equipment to measure AA and DHAA concentrations. I'm proud of all this, but I'm not telling you to brag about it. I only want to explain that I have been working with this reaction for years, and what I have done for you is develop a robust, reliable method to produce DHAA easily right at home. I've optimized the amounts and conditions for you, so that if you will follow my instructions, this is not only simple, but practically foolproof. I've tested the recovery and the stability of the DHAA in the product so that you can confidently know not only how much DHAA you've created, but how to store it properly and how long it will last. As you've already seen, we've even done an expensive absorption study to prove that it does in fact raise blood levels much higher than any other form of oral vitamin C. This video discusses the practice of consuming large quantities of vitamin C, also known as megadosing. Although this practice is common, it is not without side effects in some people. In particular, persons who have a genetic disease called glucose 6-phosphate dehydrogenase deficiency, also called G6PD deficiency, can suffer a serious reaction to taking large quantities of any form of vitamin C. Receiverin LLC assumes no liability for the use of the product described in this video. Persons who choose to ingest this product do so at their own risk. We specifically recommend that you consult a physician prior to undertaking the practice of megadosing any form of vitamin C. We specifically recommend that you do not take any more than 500 milligrams of DHAA in one day initially, and if that you choose to consume more than this, that you gradually increase the dose on subsequent days to assess your own personal reaction to larger doses. We specifically recommend that if you suffer any type of discomfort or unusual response to this product, that you immediately discontinue its use and seek medical attention if necessary. Okay, finally, right? Let's make DHAA. You'll need a blender, measuring spoons, potato peeler, some measuring cups, at least one microwavable dish or cup. You're going to need 2 ice trays, a white plate, a toothpick, and you need at least 2 droppers. You also need a timer. A wristwatch will do just fine. And you need a little jar with a lid of some type. And finally, it's very desirable. You have a digital scale that is capable of weighing at least 20 grams with a precision of 0.1 gram. I bought this one online from Walmart for less than $10, including shipping. Can you do without the digital scale? Yes, but there's a problem that I'm going to describe later. You'll need pure l-ascorbic acid crystals or powder, 16 grams for this recipe. You can buy this online from many sources and also locally at some health food stores. Please don't try using vitamin C tablets or any vitamin C product that is not just plain old USP grade pure ascorbic acid. You will have problems. You need 4 pounds of zucchini. The fresher the better. Ideally fresh picked from your own garden. The best ones are young fruits about 8 to 12 inches long. Generally, an 8 or 9 inch one weighs about a half pound, so 8 of them is about 4 pounds. Today I'm using store-bought, and I've done this many times with zucchini that I bought at the grocery store. And it said right on the rack that it was imported from Mexico. But it needs to be nice, firm, fresh-looking fruits. If the ones you find on that rack are feeling a little spongy, looking a bit dry and wrinkly, and the price is marked down, do yourself a favor and go somewhere else. You'll also need some gelatin and some water. Now these are the only ingredients that are going into the product you're going to eat. I emphasize this because we're going to need a couple of other ingredients. We're also going to use some cornstarch and some USP tincture of iodine. This is the same stuff you apply to wounds, and you can get it in the pharmacy area of almost any grocery store. But you aren't going to eat this. Instead, it is used to make the blue solution, the redox indicator that I told you about. The reagent is good for months, and there's plenty in the little jar for many batches, so you only have to make it occasionally. Let's do that first. Add 1/4 teaspoon of cornstarch to a 1/4 cup of water in a microwavable dish. Stir it so it's not lumpy. And then put it into the microwave for 30 seconds on high. Then you're going to stir it well again and set it aside to cool. You can put it in the refrigerator or freezer, set it in cool water if you want, but the important thing here is that it cools back down to room temperature. While this is cooling, make a solution of iodine. Put 2 tablespoons of water in the small container that has a lid. Then add 1/4 teaspoon of the USP tincture of iodine. And just stir it in. Now, only after the starch solution has cooled down, pour it into the iodine solution slowly while stirring. You can see that we now have a dark blue solution and that's it. We're done. You store this cap on the shelf at room temperature. I've already shown you how this works, but when we make the smoothie, I'm going to have you try this out with the puree because it looks slightly different when there's green stuff in it. Now let's make the green smoothie. We're going to make 4 cups using 16 grams of AA. When we're done, we'll pour it into these 2 ice cube trays, each of which holds about 2 cups and makes 16 ice cubes. We'll cover it with saran wrap and freeze it. So we'll have 32 cubes, each of which contains about 500 milligrams of DHAA. By the way, many ice trays make 14 cubes instead of 16, and if that's the kind you have, that's even better. Your cubes will be even closer to 500 milligrams each. The first thing I'm going to do is add 1 cup of water and a half teaspoon of gelatin to the blender. Just sprinkle the gelatin on top of the water and let it set. We're just giving the gelatin a head start on absorbing some water and becoming hydrated. The gelatin provides an inert protein that helps protect and stabilize the enzyme. You only need about a half teaspoon. More won't improve anything, but it is very important to add the gelatin. Next, I'm going to weigh out 16 grams of AA. Turn on the scale. Let it zero. Press the tare button so it goes to 0 again. And then just add the ascorbic acid until you've weighed out 16 grams. When we add this to the blender, we're not going to add it all at once. We're going to add it in increments, about 2.5 grams at a time. Now I need to explain something. This particular AA that I'm using is granular, something like the consistency of table sugar. A teaspoon of this is pretty close to 5 grams, and many of you have heard this proportion before. But the problem is that the size of the crystals makes a big difference. Some AA comes as a very fine powder, like powdered sugar. A teaspoon of it weighs much less than 5 grams, maybe only 2 or 3 grams. So if you don't have a scale, you don't really know for sure how much DHAA is in each of those frozen cubes. It might only be half what you think. The enzyme we need is mostly found in the skin and extreme outer layer of the fruit. We don't need the whole fruit, and we're trying to make a solution as concentrated with DHAA as we can. So here's what we do. First, wash the zucchini thoroughly, and then you peel each one with a potato peeler, and then peel it again. I do it like this. I count the strokes, 3, 4, 5, 6, 7, 8, 9, 10, 11. But it took to remove the first layer, and do it again. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm trying to get the green stuff off. We're not going to use these, we're going to use the skins. Add all of the zucchini skins and puree for 1 minute in the blender. If the volume is more than 4 cups, that's okay. If it isn't up to the 4-cup line, then add water until it is. It's important that this puree is fluid enough that it is mixing well and creates a good vortex in the blender. But remember, oxygen is necessary, and it comes from the air that is drawn down and whipped into the puree. So if necessary, add a little more water to assure this is mixing well. Now, if you've never done this before, I want you to test the puree at this point with the blue indicator solution. I'm going to put a drop on the plate and take a drop of the puree and put it on top of the drop of the indicator solution and stir it with the toothpick. As you can see, it stays nice and blue. That's what's supposed to happen. This is what the test will look like when the reaction is complete. I've got a cup of plain water here that I rinse the dropper out that I take the puree from blender with, you do this in between tests. Just periodically change the water so it's fresh and you don't get carryover of ascorbic acid into the next test. Now we're going to begin adding AA to the puree, but this is very important. Don't add it all at once. Add no more than 2.5 grams each time. I'm using 1/2 level teaspoon because I know that that's no more than 2.5 grams because I have a scale and I've weighed this. Blend this for 10 seconds or so, just long enough to stir it well and dissolve most of the AA. Now once again, if you haven't done this before, I want you to test this immediately, just so that you can see what the test looks like. 1 drop of the blue solution. Whoops. 1 drop of the blue solution. One drop of the puree. Stir it with the toothpick. You see how the blue color disappeared? That means that there is AA in the puree. Now there's some green color from the zucchini, but the blue color disappeared, right? Okay, cap the blender and stir for about 15 seconds. This is mixing fresh air into the puree. I told you that you need about 1 cup of air for each gram of AA. So there's actually enough air in this jar to oxidize 2.5 grams. However, we don't want it to be a limiting factor, so we do want to provide fresh air periodically to speed up the reaction. You can do this by removing the lid or the center cap while it's stirring. But if it's splattering too much, another way to shut it off, remove the lid. You can use a paper plate like a fan to push some fresh air into the jar. It makes you feel better, but in my experience, just removing the lid is sufficient. Also, it isn't necessary to continuously stir at this stage. So after 15 seconds, stop the blender, take the lid off, and just let it sit for 2 or 3 minutes. This is where your timer comes in. You know, those blender blades whipping through the puree create a lot of heat, and so does the blender motor. Remember this chart? 40 degrees is warm, 60 degrees is pretty hot, but it is definitely possible to raise the temperature of this mixture that high with constant blending for a long time. So at this stage, we're trying to minimize the actual amount of mixing time while still assuring that it gets fresh air periodically. So just repeat this process of opening the jar, refreshing the air, blending for 15 seconds, and letting it stand for 2 or 3 minutes. It will most likely take about 10 or 12 minutes to completely oxidize this first portion, so start testing it after 3 or 4 cycles of doing this. Okay, 2 more minutes have passed, and it's been about 10 minutes since we've added the first portion of ascorbic acid. I'm going to give this a stir, and now I'm going to test it and see if the oxidation is complete. Put a drop of blue reagent on the white plate. Make a drop of the puree. Put it on top of the reagent. Stir with the toothpick. You can see that this is not turned completely clear, but it's not dark blue either. That's what that really means, is it's just about done. So let's put it through one more 2-minute cycle and test it again. Okay, now it's been 12 or 13 minutes since we added the first AA. One more time, a drop of reagent. A drop of the puree. Stir it with the toothpick. That's what we're looking for. It stays nice and dark blue this time. That means that there's 2.5 grams of DHAA we have already created in the blender. Once the test stays blue, indicating complete oxidation, you can add more AA, and from here on out, the reaction will proceed much faster, oxidizing each additional portion in about 3 or 4 minutes. So here's what I do. I get the mixture stirring and then remove the center cap. I've actually made this little cover by cutting the top off a club soda bottle that happens to fit nicely on my blender. It stops most of the small splatters, and this small hole still allows plenty of air. I add a ½ teaspoon of AA, wait 4 minutes while it's constantly stirring, and then just put in the next ½ teaspoon. I repeat this every 4 minutes until we've added all of the 16 grams. It's been another 4 minutes. At this point, there's less than 2.5 grams remaining of our original 16, so I'm going to add the entire remainder of the AA right now. If you want, you can even rinse the little cup out with a little water to make sure you get every last milligram of AA. And since this is the last addition, I'm going to turn it on to stir, and I'm just going to let it go for a full 10 minutes. About 10 minutes after the last addition of AA, it's time to start testing. If it isn't completely oxidized within about 15 minutes, it probably won't ever be completely oxidized. We'll talk about that in a minute. There's 1 drop. Whoops. 1 drop again. We'll test it in duplicate. It's still starting to turn clear, so we're going to turn it back on and let it mix with air. Okay, now it's been about 13 minutes since the last addition of AA. There, that's what we're looking for. Stays nice and blue. It means it's completely oxidized. We've completely oxidized 16 grams of AA to DHAA. If you followed my instructions carefully and this failed, it's almost certain that your zucchini was just not fresh enough and lost too much of the enzyme activity. And all you know about the puree you've got is that it contains somewhere between 2.5 grams and 16 grams of DHAA. So, if you don't want to take that chance, what you do is test it and let it go to complete oxidation after every addition of AA. This takes a little longer, but if the enzyme gets exhausted before you've added all 16 grams, you'll know pretty close how much DHAA it actually contains. Here's another thing. It is possible, in fact very likely, that there is still plenty of enzyme activity to keep on oxidizing AA in this puree even after adding 16 grams. So at this point, you might choose to add another 2.5 grams and keep going. If you're going to do this, however, always test each additional portion and let it go to complete oxidation before adding another portion. At some point, the enzyme will become exhausted and the reaction will stop. As I told you before, a good rule of thumb is this. If it takes more than 15 minutes to completely oxidize the last portion that you added, then the enzyme is probably exhausted. I have made batches using this technique that are 2 or 3 times more concentrated than the one we just made. In other words, it is possible to continue this reaction such that each of your final ice cubes contains as much as 1,000 or even 1,500 milligrams of DHAA. It all really depends on the quality of the zucchini you start with. But we've reached our goal for today, so I'm just going to talk about what we have, what to do with it, and why. First of all, I've tested this product immediately after it is made and found that it contains about 95% of the expected amount of DHAA. In other words, we added 16 grams of AA, and actual measurements show that there's more than 15 grams of DHAA in the final product. DHAA is a notoriously unstable chemical, so I've also tested the products to determine its stability under various storage conditions. If you leave this warm puree at room temperature, in 12 hours, about 25% of the DHAA will decompose. So we want to use this or store it properly within the next couple of hours. However, if you put this in the refrigerator, in 12 hours the loss is only 5%. So you can reasonably keep a portion in the refrigerator for use within the next 24 hours. When I froze this and then tested it 2 weeks later, the loss was only 5%. So it appears that you can store this in the freezer for at least a month and it will still have at least 90% of the original DHAA concentration. So I'm going to pour this into ice trays, cover them with saran wrap, and freeze it. After that, I break the cubes out of the trays and put them in a Ziploc bag that I store in the freezer. So each cube contains nominally about 500 milligrams. If you do the math, the actual number is about 450. If you use ice cube trays that make 14 cubes instead of 16, then your cubes will actually contain slightly more than 500 milligrams on average. And obviously, you can freeze this in any containers and in any quantities that you choose. And finally, maybe you're wondering what it tastes like. It is completely bland. It tastes pretty much like you'd expect a puree of zucchini to taste. I'm sure there are ways to make it more flavorful, but keep in mind what I told you before. If you add sugar, including fruits that contain sugar, it competes with absorption and your blood levels of vitamin C won't go as high.